Every time you run an AI workflow through a standard cloud provider, you are bleeding capital. You build the pipeline and you parse the data, but you don't own the intelligence. You rent it by the token. When a provider raises prices or suffers an outage, your entire operation grinds to a halt. Today, we sever that connection. We are going to build a completely sovereign AI brain that runs entirely on your own physical hardware. Once the machine is built, the cost of processing a single document is limited only by your local electricity and maintenance. This local architecture relies on a trinity of open-source tools. n8n acts as the nervous system, routing your data securely. Ollama serves as the localized inference engine, replacing complex Python setups. And DeepSeek-R1 provides the cognitive core to process logic and reasoning. Before we begin, you need to check off two prerequisites. First, install Docker on your machine to manage our isolated environments. Second, you need a minimum of 8 GB of physical memory, either RAM or VRAM, to ensure the models can load into your system. By shifting this stack from the cloud to your local machine, 0 bytes of proprietary data ever leave your network. You stop acting as a tenant on someone else's server and become the architect of your own data infrastructure. We start by deploying n8n. This is the air traffic controller for your digital workforce. It directs the flow of incoming documents and database queries without relying on an external internet connection to execute its routing logic. To install it, use the n8n self-hosted starter kit via Docker. A simple terminal command places the n8n engine inside an isolated, containerized network. Once finished, open your browser. You should see the n8n dashboard actively running within its secure partition. Because this environment is hermetically sealed, your workflow data cannot accidentally leak out to the broader internet. The system is entirely deaf to the outside world until you explicitly authorize a connection. But bringing the brain in-house introduces a physical constraint. If you attempt to load a massive, uncompressed language model, it will crash a standard consumer GPU with an out-of-memory error. To solve this, we rely on quantization. We mathematically compress the model's weights from 16-bit floats down to 4-bit integers. This reduces the required memory footprint by 75% while preserving most of the network's factual accuracy. Drop a comment below with your exact RAM and GPU specifications. I use these metrics to optimize the architectures in upcoming tutorials so they run reliably on your specific hardware. Now, open your terminal and type Ollama poll DeepSeek-R1. This command instructs Ollama to fetch the compressed DeepSeek-R1 reasoning model and install it directly into your local environment. Quantization transforms enterprise-scale intelligence into a compact, resource-efficient engine. This is the mechanism that makes local autonomy physically possible on standard consumer hardware. We now face an infrastructure hazard. Because we containerized n8n for stability, it operates in a sealed box. Standard local host routing fails here. The n8n container is physically blind to the Ollama engine running on your host machine. To bypass this block, you must explicitly route the API endpoint through host.docker.internal. This forces the container to punch a specific hole through its isolated network to speak to your hardware. By forcing this internal bridge, the orchestrator and the cognitive core can successfully communicate in total privacy, bypassing the need for any external IP addresses. Avoid the monolithic prompt error. If you throw a complex, multi-step objective at a local 8 billion parameter model, its attention mechanism will likely fragment, leading to reasoning failures or repetitive loops. We solve this by deploying a multi-agent triad. We divide the cognitive workload into 3 specialized roles. The planner breaks the objective into mathematical steps, the worker executes the tools, and the critic evaluates the output against the plan. DeepSeek-R1 is uniquely suited for the planner and critic roles. It initiates an internal monologue, explicitly debating the logic before rendering a final decision. By restricting the model's focus to distinct divided tasks and forcing it to verify its own logic, we create a self-correcting feedback loop. This architecture significantly reduces hallucinations, delivering reliable outputs from a compact local model. This chart compares the cost of renting API access against owning the physical hardware. While the cloud costs scale linearly with every request, local operational costs remain relatively flat once you've accounted for electricity. For high-volume workflows, the upfront hardware investment often pays for itself through the elimination of per-token fees. By finishing this build, you achieve 3 things: 0 data leakage, zero API subscription costs, and absolute architectural sovereignty. You are no longer vulnerable to external rate limits or service changes. If this blueprint successfully helped you eliminate your cloud dependencies, strike the like button to share this architecture with others. This brain can now reason securely, but it currently lacks long-term memory. In the next video, we will wire this triad into a vector database to solve the problem of local model amnesia. In the modern data landscape, true power belongs to the sovereign architect, not the cloud tenant. End of transmission.